Happy morning to one and all. Today we want to take the new chapter about the overhanging beam. So while I am taking the class, I would like to recap the previous thesis along with the DT approaches. So the above guys are they want to discuss with the previous class topics with you all. Thank you.
Hello everybody, myself Viram Pardi from Mechanical Department. Now I am going to share types of beam in SOM. In SOM, strength of materials. The beam is a structural membrane that plays a major role in loads on perpendicular to its length. There are 5 types of beam, such as simply supported beam and a cantilever beam, overhanging beam, and a continuous beam, and a fixed beam. Now we go to the first. We go first with the simply supported beam. Simply supported beam is both ends are supported, which one end is a hinge and the other end is a roller. This beam is come across all our problem in our SOM. And cantilever beam is nothing but one end is a fixed end and the other end is free. In the fixed end, the bending moment occur mostly, and so free end is free end occur freely. Overhanging simply supported beam that may occurs one or both supports, one or both many supports, which is known as overhanging beam. And fixed beam is used in structural weights that both ends are rigidly fixed, which is used mostly in buildings such as higher complexes and bridgeways, heavy load areas. And a continuous beam. In continuous beam, the supports occur more than one or two supports, which is known as continuous beam. It is heavily used, which is mostly used for heavily structural materials. Thank you.
Hello friends, I am Viram from Mechanical. Now I am going to tell you about types of beams, types of loads acting on a beam. In this we have 4 types: point load, point uniformly distributive load, then uniformly varying load and moment load. Point load acts on one point. It acts at a column. Next, uniformly distributive load. Uniformly distributive load spreads evenly on the length of the beam. Next, uniformly varying load.
This element carrying the point to point variation, that's why it is called as a UDL. Thank you.
Second year mechanical engineering, SNS technology. I'm going to talk about how beam is applied in a strength of material SOL. In a strength of material, in a beam is used to study about the freely to fix it in the applied load, and when a load is applied in a beam, it is bent to because of its internal stress, bending moment and the shear force, and in a bending moment to apply the shear force to maximum calculating the formulas, and it is used to day-to-day life like bridges and buildings and machine frames, and so engineers to fix the idea about the beams to design and strength and the technologies. Thank you.
So hi, myself Harish, a second year mechanical engineering student. So I am going to recall the content of shear force diagram and bending moment diagram. So what is shear force diagram? The shear force diagram shows the variation of the shear force in the beam. So here the point load shows the sudden change in the line. Then we talk about the bending moment diagram. Here it shows the variation of the bending moment in the beam. So normally in the problems we can see how the problem given according to the given sum. So here first we draw the rough diagram of the sum. Then we go for the shear force diagram. Then again we will go for the bending moment diagram. Here each to find the each diagrams we have several formulas to find it. So the conclusion will be concluded by Manish.
Conclusion about beam. Beam are important structural members. Different types of load create shear force and bending moment. SFD and BMD help us understand internal force. Proper design prevent failure. Strength of material helps engineers design safe and stable structure. Final line. Understanding beam loads, shear force and bending moment is essential for safe structure design. Thank you.
So in the space diagram, first of all, we would like to calculating the space diagram initially. After we go with the shear force diagram. While we go within the shear force diagram, we can be concerned with the help of space diagram. Once the space diagram is constrained, we can calculating the position calculation. It is nothing but the beam total travel to the length, like A to B or A to X and so on. So, for example, RA plus RB we want to calculate means we can add the total loads. After getting the total loads, we can divide by the total span of the length. So we get easily from the A point to another X unknown point. So based on the calculations, we go with the bending shear force calculations. The shear force is only calculating with the help of load can be acted on the particular pivot points. Compared with the bending moment diagram, along with the loads, we want to add or multiply with the distance. So load into distance formula we can utilize this. So based on the calculations, we can construct the diagram parallelly. So this is, or shall we go with the new topic? There is no problem. Thank you.